So now that we understand probability a little bit, let's think about how we can actually calculate it. Now, we're going to start off by keeping things pretty simple. We're going to make a simplifying assumption, okay? And our assumption is that all the outcomes in a sample space are equally likely. All outcomes in the sample space are equally likely. And so we're going to use this simplifying assumption for this section. So what does this mean? This means that every possible outcome has the same chance of happening. Most of the examples that we've talked about so far, this is the case. If we roll a die, every number the die can land on has the same chance of happening. If we flip a coin, just as likely to land on heads as tails. They have the same chance of happening. They are equally likely. If we draw a card from a deck of 52 cards, every one of those cards has the same chance of being drawn. Right? They are all equally likely to occur. So this is an assumption, but it's an assumption that's not unreasonable in a lot of circumstances. Okay? So then how do we calculate the probability? Let E be an event. Then the probability that E happens, the probability that event E happens, if all the outcomes are equally likely, is equal to the number of outcomes in event E divided by the total number of outcomes in the sample space. So in this special circumstance where all the outcomes are equally likely, all we have to do is count. We count how many outcomes are there in event E, how many outcomes total are there in the sample space, and we get that fraction or proportion, and that will tell us the probability. Okay? So let's take a look at a simple example, one we've dealt with a lot. Okay? Consider tossing a coin. Let H be the event that the coin lands on heads. Now, as we said, this experiment, all of the outcomes are equally likely. We're just as likely for the coin to land on heads as tails. So let's see what our formula has to say about this. Okay, so if we apply the formula, we want to find the probability that the coin lands on heads if we toss the coin. Okay, so use our formula, probability that the coin lands on heads. According to the formula, we count the number of outcomes in the event. So the number of outcomes in H, we've named our event H in this case, divided by NS. Remember, S stands for the sample space, so the number of outcomes in the sample space. Okay? Well, if we think about this experiment, maybe start with the denominator. What's our sample space? What are the possible outcomes? Well, there's only two possible outcomes here, right? We could land on heads or we could land on tails. So the number of possible outcomes in our sample space is 2. There are 2 ways that we could, there are 2 possible outcomes that could end when we toss this coin, right? What about NH? What are the number of ways we could land on heads? Well, there's actually only one way to do that, right? That is, the coin actually lands on heads. And so using this formula, we get the probability that we expect. Okay? There's one way to land on heads out of 2 possible ways that this coin could land, right? So we get 1/2 or 0.5, 50%. There's a 50% chance this coin lands on heads. Okay? Good. So that kind of confirms our formula here because we're getting the probability that we expect. Okay? Let's look at one more example, a little more complicated. Okay, consider rolling a 6-sided die. Let event A equal 1, 3, 5, 6. Actually, let me rephrase that. Let event A be the event of not rolling a 2. Find the probability of A. Okay? So we're rolling a 6-sided die. And when we're rolling a 6-sided die, all the outcomes are equally likely. Every number has the same chance of showing up, right? So according to our formula, to find the probability of an event A when all the outcomes are equally likely, we count the number of outcomes in event A, the event we're interested in here, okay? And then divide by the total number of outcomes in the sample space, okay? So how many outcomes are there in event A? Well, let's count, okay? Event A is the event of not rolling a 2. So everything but a 2 is okay. So that could be 1, but not 2, or 3, or 4, or 5, or 6. Everything that's not a 2, okay? And we want the number of outcomes in event A. So that's 1, 2, 3, 4, 5. So there are 5 ways that event A can happen. And we're going to divide by the number of outcomes in the sample space. How many outcomes are there in the sample space? We're rolling a 6-sided die, okay? And so there are 6 ways to do it. There are 6 sides for the die to land on, okay? So we get 5 out of 6, which is, let me put in my calculator off to the side here, that's about 0.83333. So about an 83.33% chance that we won't land on a 2. Okay, that's the probability. So this is the way we're going to calculate it in the section, so not too complicated. It is important to note, though, that not all experiments have outcomes that are equally likely. We're assuming it for this section. That's all you need to worry about for this section. But it is possible that there are experiments where the outcome is not equally likely. For example, say we have the weather forecast predicts that tomorrow there's a 70% chance of rain. Okay? Well, there's only 2 outcomes. It could rain or it could not rain. But the 2 outcomes are not equally likely. The chance that it rains is 70%. The chance that it doesn't rain is only 30%. It's more likely to rain than it is to not rain. In that case, this sort of situation, this sort of probability calculation does not work. Now again, you don't have to worry about that for this section. In future sections, we'll learn about how to calculate the probability or how to deal with probability when outcomes are not equally likely.